You are welcome to this video. In this video, I'm going to talk about alkynes. Now, this is the general formula for alkynes. And I mentioned in my previous video that the N represents the number of carbons. The N represents the number of carbons. So to get your alkynes in series, you just put in your positive number here, positive integer here. That is from 2. Now, alkynes, you can't have an alkyne with just one carbon because they form triple bond. So to form the triple bond, this is how they look like. An alkyne will look like C, 1, 2, 3, then C. Now, with the triple bond, when I write just the C here, and I just put 3 lines in front of it, this cannot form it cannot form an organic compound. There should be another C. Now, I mentioned that carbon is tetravalent, meaning that it can bond to 4 electrons. So you have 1, 2, 3 here. 1, 2, 3. So this carbon needs another one to be 4. So you put 1 here, 1 here. And I mentioned in my previous videos that every single bond involves 2 electrons. So this carbon has 1 electron here, 1 electron here, 1 electron here, 1 electron here, 1 electron here. So you put your hydrogen here and hydrogen here. So this is the first member of an alkyne. It's similar to that of alkenes. So with alkenes also, I mentioned that their first the first member of an alkene has 2 carbons. But for alkenes, you can start from 1. Yes. So let's look at how we can name some simple alkynes. So since I said the number of carbons starts from 2, so we start from 2. When N is 3, when N is 4, when N is 5. So I already mentioned that an alkyne cannot have a single carbon. So we move from there and we come to the next one. So how would the structural formula of an alkyne with 2 carbons look like? So we are going to have C2H. Now 2 times 2 give you 4 minus 2. C2H2, because 4 minus 2 give you 2. C3H, 3 to 6 minus give you 2. C4H6, C5H8, C6, H10, C7, H12, C8, H14, C9, H16, then C10, H18. Now it looks like I didn't get it right. Okay, so let me just match them. Let me just make a line to match them. I think my black marker has a very big tip, so okay. So let's see. Now in alkanes, I mentioned that the video in alkanes, I mentioned that when the number of carbons is 1, we're going to call it meth. But since 1 is not here, we can just ignore it. When the number of carbons is 2, it's going to be eth. So ETH. 1 is 3, it's going to be prop. 1 is 4, it's going to be but. 1 is 5, it's going to be pent. Okay. So if you are new to this video, let me just do a little recap. So we mentioned that the number of carbons you have in an organic compound will determine how you are going to name the beginning. That is the prefix. So when the number of carbons are 2, it's going to be eth. When the number of carbons are 3, it's going to be prop. When the number of carbons are 4, it's going to be but. When the number of carbons are 5, it's going to be pent. When the number of carbons are 6, it's going to be hex. When the number of carbons are 7, it's going to be hept. When the number of carbons are 8, it's going to be oct. Number of carbons are 9, it's going to be non. Then when there are 10, it's going to be dec. So the next thing you look at is the suffix of the organic compound. It ends with Y and E. Y and E. So this one is going to be called ethyne, propyne, butyne, pentyne. So just keep adding the Y and E. Heptyne. This hexyne, heptyne. Octyne. Nonine. Then decyne, DCYNE. The sign. So this is the way you name simple alkynes. Yes. So let's continue to look at how we can draw a structure for butyne. I just want to choose butyne. So butyne is C4H6. So we are going to have 4 atoms of carbon. 1, 2, 3, 4. Now, since alkynes have 3 bonds, since alkynes have triple bonds, it means that the triple bond is going to be located somewhere. So let's say I want to put the triple bond here. 1, 2, 3. Yes. Now we know that every carbon should bond to 4 electrons. So 1, 2, 3. This carbon has 1, 2, 3. So I can add 1 here. So I have 4. This carbon also has 1, 2, 3, then 4. Now this carbon has only 1. So I can add 1 here, 1 here, 1 here. So this carbon has 1, 2, 3, 4. This carbon also has 1, 2, 3, 4. When I choose to put a bond here, it's going to be wrong. Why? Because every carbon is supposed to have 4 electrons. So it's going to be 1, 2, 3, 4, 5. So it's going to make everything wrong. Yes. So that's why it is done that way. So I'll just fill with my hydrogen, 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 and hydrogen. So this is the structural formula. Let's look at how we can write the molecular formula. So the molecular formula is going to be CH, this C here, this H here, then your triple bond, 1, 2, 3, then this C, then this C with a H2, then this C with 1, 2, 3, so H3. Now when you are naming alkynes, you state the position of the triple bond and you use the least number. Now when you start counting from here, 1, 2, 3, 4, you have 4 carbons. The triple bond is on the first carbon when you start counting from your left, which is this part, to your right. Now when you start counting from your right to your left, 1, 2, 3, it is closest to the 3, the third carbon. Now according to the nomenclature of alkynes, or yes, organic compounds, you use the least number. So from here is 1. So to name this, we know, although we know is butyne, when you have a structural formula like this, you need to state the position of the triple bond so that someone can also draw the same. So it's going to be called 1, 2, 3, 4. 4 is but, so but 1 hyne. The 1 here is showing you the position of the triple bond, or you can call it both 1 hyne or 1 butyne. They are all correct. So how can we draw the structure for this and then name it as well? So let's see. This C, so we write our C. Now with the H3 means that it has 3 hydrogen atoms around it, so H and then H. Now this another C again. Since the triple bond is in front, it's in front here, so 1, 2, 3. We have another C here. As we explained, this carbon has 4 electrons around, this one also has 4, so we can move on. C. Now this C has H here, another H here. Now this C is here, the H is 2, so another H here, another H here, and this C has 3 H around it, so 1, 2, 3, H here, and another H here. So how do we name this? First of all, we count the number of carbon atoms. 1, 2, 3, 4, 5, 6. 6. So we are looking at hex or hexine, yes. But we can't just see hexine. We need to look at the position of the triple bond. Counting from your right to your left, 1, 2, 3, 4 is closest to the fourth carbon. Counting from your left to your right, 1, 2 is closest to the 2. So we are going to call this hex 2-ine or 2-hexine, Hexyne. So you can pause the video and try to name this one as well. Okay, so let's continue. You have an alkyl group here. 1, 2, 3, 4. So you have 4 carbons and with an alkyl group here. Now, if you don't know what an alkyl group is, I'll urge you to watch my video on alkenes. I described what an alkyl group is. It's a substituent, and these substituents have a general formula CnH2n plus 1. Now looking at this one, this is CH3, so it means that the N is 1. So CH3, since the N is 1, we're going to call it meth. So it's a methyl group. Yes, alkyl group, sorry, but the name is methyl. So when you're naming organic compounds, you name the substituent first. So why the substituent is an alkyl group. So to name it, you need to have in mind that you are going to first of all consider the position of the triple bond before naming this one. So first of all, let's look at the triple bond. It's found on the first carbon. Yes, it's found on the first carbon. And when we start counting from here, it's found on the first carbon. When we start counting from here, it's on the 1, 2, 3. So we maintain the first carbon. Now, since we started counting from here to get the name for the alkyne, this remains our starting point. We don't now come and then count from here again. So this remains our starting point. So to know the position of the alkyl group, you now count 1, 2, 3. Since the alkyl group is on the third carbon, we are going to call it 3 methyl. Then you count the number of carbons, the longest chain, 1, 2, 3, 4. 3 methyl but 1 ine. So that is the correct name, 3 methyl but 1 ine. So with our third example, you can also pause the video and try to do it as well. So let's see, you have 1, 2, 3, 4. 4 long carbon chains. So 1, 2, 3, 4. And you can see there is an alkyl group here. This is an alkyl group, but it has 2 carbons. So it's an ethyl. And you have the double bond, sorry, the triple bond. You have the triple bond, 1, 2. So counting from here is 1, 1, 2. Counting from here is also 1, 2. So we have 1, 2, 3, 4, 5. 5 carbons. So we are looking at pent. So you're going to have pentyne. But the issue is with the triple bond. So counting from here is 1, 2, 3. The triple bond is found on the third carbon. When you count from here, it's on 1, 2. So it's on the second. So we are going to call it pent2-ine. But this is ethyl. So it's going to be, it's on the first carbon. So since on the first carbon, we are going to state the position of the ethyl. So the name is going to be 1 ethyl pent 1, 2 2-ine. Or some people can go this way, 1 ethyl 2 pentyne. But I prefer to always go this way with the 2 in between the pent and then the suffix of the organic compound. Now this third question could be a little bit trickish, but let's see. 1, 2, 3, 4, 5. Now we always use the longest chain. So if you end at 5 and you call this an alkyl group, you have messed everything up. You're always using the longest chain. 1, 2, 3, 4, 5. Now we can extend this, as in we can write this in the simplest structural formula. It's going to be 2 carbons continued. So it's going to be 1, 2, 3, 4, 5, 6, 7. So instead of calling this maybe 1 ethyl pent 2 ine, because you are thinking it's 5, 1, 2, 3, 4, 5, you are not using the longest chain. So you might be penalized for that. So it's 1, 2, 3, 4, 5, 6, 7, because you're always using the longest chain. Since you are using the longest chain, this is not an alkyl group. So the name is going to be, counting from here, you're going to have 1, 2, 3 on the third carbon. But counting from here is going to be 1, 2, since you have 2 here, 2 carbons, 1, 2, 3, 4. So we are going to maintain our counting from here. So it's going to be 1, 2, 3. So since you have 7 carbons in the longest chain, it's going to be hept 3 ine. So take note of something like this. You're always using the longest chain, so take note. So you can pause the video and try this one as well. So let's see. You have 1, 2, 3, 4, 5. Now take note. This is a sixth one. 1, 2, 3, 4, 5, 6. So now you know how to identify the longest chain. So that the triple bonds is found on the first carbon. The triple bond is found in the first carbon, and you can realize you have Cl here, Br here. Now these Cl and Br, they are inorganic substituents, chlorine and fluorine. If you watch my video on alkanes, I mentioned that chlorine in an organic compound will be called chlorine, and bromine will be called bromo. So you have 1, 2, 3, 4, 5, 6. Okay, so you know you're going to have, since the 6 is going to be hexine, or yes, since the triple bond is found in the first carbon, it's going to be hex 1 ine. Now looking at the since they are substituents, you know their name is going to come. Their names are going to come before the longest chain, that is hexine. But you realize that this chloro and this bromo, you always name the substituents in alphabetical order. So bromo will come before chloro. So since this is our starting point, 1, 2, 3, 4. So it's going to be 4 bromo, 1, 2, 3, 3 chloro. You realize that anytime I have a number in a letter, a hyphen comes. So 4 bromo, 3 chloro, hex 1 ine. Yes, 4 bromo, 3 chloro, hex 1 ine. So that is it. Now when you have an alkyl group, an organic substituent, and then an inorganic substituent in an organic compound, you name the inorganic substituent first. Let's just see one more example on that. So it's our final question on naming of alkynes. So looking at this, we have 1, 2, 3, 4 longest chain. Yes. So we have an alkyl group here, as well as we have a halogen. Now we have an alkyl group and a halogen. You name the halogen first. But you know our priority is the triple bond. So it's on the first carbon. So we know you are going to have 1, 2, 3, 4. 4 carbons. You are going to have both 1 ine. But before that, we have to name the halogen first before the alkyl group. So the halogen is on the first carbon. So it's going to be 1 chloro. So these are starting points. 1, 2, 3. 1 chloro, 3 methyl or methyl. 1, 2, 3, 4. Both 1 ine. So that is our answer. So let's look at properties of alkynes. Properties of alkynes. So 1, they undergo combustion reaction. What is combustion? Combustion means burning. Now, oxygen is needed in burning. For burning to take place, you need oxygen. So you have an alkyne C3H4. plus oxygen to get, after combustion, you always have carbon dioxide and water. Now, you have 3 carbons here, so you just place your 3 here. And to just make things faster, I believe you put 2 here. Then put your 4 here. Now, this equation is balanced. So, this is an equation for combustion in alkynes. One thing you should know is that alkynes will burn incompletely in a limited amount of oxygen. So carbon monoxide rather will be produced instead of carbon dioxide. So the second reaction. So the second point, they undergo addition reaction. And an example of addition reaction is hydrogenation. So addition of hydrogen. Now, with addition of hydrogen, you know that our alkynes have triple bond. Now, when you add hydrogen, you're going to reduce the number of bonds. So let's see. Carbon with 3 bonds. You have your H here, you have another H here. So hydrogenation plus hydrogen gas. You are going to reduce the number of bonds. So it's going to be 2 bonds now. So you have 1, 2, 3, 4 around each carbon, 1, 2, 3, 4 around each carbon. So that's how hydrogenation works. And there's another form of addition reaction which is known as halogenation. So halogenation simply means addition of halogen. So you have your ethane here, H here, another H here. So your halogen. So let's go for bromine, Br2. So after this reaction, we are going to have C double bond C. So H here, Br here, H here, Br here. So as simple as that.